All right, so you might get a quiz. Most likely it'll look like this, one of the quizzes. And it's gonna have the title. Obviously, you would have put your name on your paper. You don't see the title up there. Let me make sure you see it. I might give you something. Let's say you put your name on the upper right-hand corner of the paper. Right, that's what you would be doing on the test. It would be nice sometimes if you put your period, just in case the paper gets scattered on a different stack. And then the title here, you would call this Empirical Rule. So that's one point. And then I'm gonna have like this. It's gonna be like this, and you're supposed to write what's the percentage there gonna be from within one standard deviation of the mean. What does the empirical rule say? It says 68. However, I know what you mean by the 34. The 34 is the piece from here, from 0 standard deviations, from the middle to the end. So you're gonna have to do that too, right? And then for 2 standard deviations, what is it? 95. 95% of the data. And a key word here is the word about. You don't have to write it there, but just remind you, about is the key word there. Oh no. I tried to be slick and look what it did. Wait, let me see if I can drag it. Of course not, because it would be awesome if everything works right. Let's try this again. All right, let me see. I think I can do this. Come on. Yes. So smart. There we go. I moved it. The reason I did that is because I need another level right here. So then the next part of this, wait. Oh, by the way, what does this piece here going to be? 13.5. Yeah. 13.5. And then we have from all the way over here to all the way over there. $99.7. And what would be the percentage for thing from 2 to 3? Be 2.35.
Good morning. Please excuse the interruption. Teachers at this time, please read any students who on the list that was sent this morning to your email. These students are scheduled to take the SPLE today. The list includes their assigned location. Good luck, gladiators.
All right, so far so good. Now, I would like you to just do the last piece. And it's nice to realize that these tails go to infinity. And the last piece remaining is 0.15% each of the tails. To, if you were able to go to infinity. All right, so that's the empirical rule. And that's one of your quizzes that you'll be taking next class. Yes, please remember that. It's not too hard to remember because if you take 1 and you subtract 0.997, you get 0.15, 0.30, sorry. And you take 0.30 divided by 2, you get 0.15. Does that make sense? If you did miss or forgot it, I'm going to be lenient, but this is one of your quizzes, and I think it's a fair quiz. I mean, obviously, what I think doesn't matter, right? It's just a quiz, right? In the long run.
Right now, to us, it's not just a quiz. It's our grade. Next year, we'll forget about it.
I'm telling you, it doesn't matter. Don't look at it that way. It's not that important. You just do your best and you move on. No, listen, it doesn't matter. It's not interesting. It's not worth fretting over. Just study, do your best, and take it for what it is. Just something make-believe that we're doing with our life right now. This is make-believe. You're not even gonna use this in real life. I mean, is life real? Where? Another test.
And in psychology, we do that.
Yeah, I know, because it's something academic, but like, it doesn't matter. Like, Ask your parents if they use this. Most of us that are not at the extremes of well, at the upper extreme of academia or something like that, we're not going to use this. We're not. You're not going to use this. This is a select group of people, not even select, just a small percentage of the population that might use this. And this is, I'm being honest. I think you guys know this. Like all the stuff you read in literature, do you really use that? I know. I sad. You had to read that. I know. Oh, but it makes you, it educates you. Yeah, I guess so. Yeah, sure. All right, so let's go to the next section. I'm gonna go ahead and do this here. I mean, I'm not trying to belittle it in the way I am belittling it. Doesn't mean you shouldn't study. Oh man, I have a meeting today. Okay. Why, Brian? Okay, so the next thing I want you to be able to do on your test is I want you to be able to solve problems from the empirical rule. So one quiz will just be, hey, can you do this, whatever. All right, can you fill out the rule for the empirical rule? Do you know the name of the empirical rule? You know, like if you don't put the title, you don't remember it's empirical rule, that means you don't know it. The next thing I want you to be able to do is I want you to be able to answer a question like this. Like let's say there is a sample of 19 football players weight, right? And I would say the mean was 200 pounds. And the standard deviation was, I don't know, 20, just to make numbers nice, 20 pounds. Right, so that's the situation. And so I might ask, let's say, about what percentage, let's put 190 football players just to make it more interesting. So instead of 19, let's put 190 football players weights. About what percentage of the football players weights lie from 200 to 240. So what I would expect you to do on a question like this is I would expect you to make a quick sketch of the situation. Now, something I should do is I would have to say here, very important thing I should add to this question. I would have to say, assume the distribution is bell-shaped. I should do that. So now you would go ahead and draw this and you'll put, where you put the 200, the mean, where do you put it? Yeah, you would use X bar here. And then at 1 sigma, what will one S, sorry, be? Because this is a sample. What would S be? 220, right? Because it's 20 more. And then what about 2S? 240. So about what percentage of football players weights lie from 200 to 240? And you would just simply, okay, that's this area here, and this area here, all that combined. So you know this is 34, and this is 13.5. If you add those two together, if you take 34 and add 13.5, you get 47.5. So you would say, at the end of the day, you would say about 47.5%, and this is the key word here, about 47.5% of the players' weight should be between, and inclusive as well, between 200 through 240 pounds. Super simple question, I think. Now, the second type of question I might ask here is, I would say, about how many players would we expect to have weights between 200 through 400 pounds? And you can't see it because it has to go up. What? It's not seated in? Give it a second. It's gonna say, there you go. It appeared. So it says, about how many players would you expect, pretend I wrote you there, to have weights between 200 to, did I put 400? 240, sorry. 240 pounds. So how many players did we start this question off with? How many players? 190, right? So what percentage of the players are between 200 and 240? We answered that previously, right? 47.5. So what we do here is if we have 190 players, and if we multiply it by the decimal representation of 47.5, that's how we would figure out about how many players we would expect. So 47%, 47.5% of 190 is what we will be solving. And that's how we do it, right? It's almost half. So 0.475 times 190, and I get 90.25. So 90.25. So I would say I would expect about 90 players. I would expect about 90 players to have weights between 200 to 240 pounds. So very simple question. Remember, the empirical rule is the type of rule that's an approximation. And for the most part, we're always making approximations. And it's based off this bell shape. Remember, you cannot use the empirical rule for anything that's not bell shaped. Okay? Questions or concerns? It's pretty easy, right? But this quiz is not going to just have empirical rule. It's also going to have something referred to as Shapeshift's theorem on it. I mean, I could make it into just one quiz on empirical rule, one quiz, the chart, and I can make another quiz on Chebychev's, and that'll be 3 grades right there and then. Because what happens is when I roll this all into one quiz, a lot of people get the chart right, a lot of them get this right, but then you mess up on Chebychev's rule, you end up with a C. Right? But let's say you get 2 A's and 1 F. Is it not C2? You see how it works out? Like you can't escape it. So it's 4 plus 4 is 8 plus 0. 8, what's 8 divided by 3? 8 divided by 3, assuming they're all equally weighed. 2.6, it's a B. It's better though. It's a B. Borderline C, but still B. Okay, so let's talk about Shapeshift's theorem. I'll throw it to right. I'll wait because some people are writing. Okay, so let's talk about the next thing. It's called Shapeshift's theorem. So if you remember Shapeshift's theorem, it's 1 minus 1 over k squared. That's the key thing. And the key word in Shapeshift's theorem is at least. So I might ask you a similar question to the previous one. So I might ask you, what state Chebychev's theorem? Something like that. You would say for any distribution, now, strictly speaking, if it's a normal distribution or it's bell-shaped, we'll use empirical rule, but Chebychev's theorem applies to any distribution. We usually use it when we don't know the shape. For any distribution where k is greater than 1, k stands for what? The standard deviation. For any distribution where k equals 1, at least 1 minus 1 over k squared must lie between x bar plus or minus ks. So k stands for these standard deviations. So you would say something like that. The word at least here is important because, as you know, if you don't say at least, that means a lot of us want to say, oh, about 75% when k equals 2, let's say. That's not how it is. You could have all your data lie there, it could be all of it because it's at least 75%. So we know for k equals to 1, you put it in here and you get 0. And I might say for number 2, for k equals to 5, at least how many percent would you expect? Let's say I could give you something like that. And then you would go ahead and you would say, okay, 1 minus 1 over 5 squared, which is 1 minus 1 over 25. All right, let's continue. All right, so what does that give you? 24 over 25. So 24 divided by 25. That's 0.96. So what will you say? At least 96% of the data must lie within. Oh, that's great. Thank you. Oh, there, it's coming, but it's not. Oh, there you go. It's just doing too many things at the same time. Just here in a second. At least 96% of data must be within 5 standard deviations from the mean. Make sense? All right, we cool? We get it? As I can see, my bullying about masks didn't make a change on some people's things. Damn, I have to take that out now too. All right, so what else can I ask you? Well, I can ask you this same question various ways, but I think that would be the extent of what I would like you to do on Chebychev's. You know, I could ask you k equals to 3, k equals to 4, k equals to 10, and you should be able to show me the work and do it. And you should remember that word. The most important word here is the word at least. Okay. So now let's proceed. And we're going to talk about the Boxplot stuff. And z-scores, of course. Oh, no. Okay. Oh, here we go. Text messages from my wife. Now she's telling me, here's what my wife tells me. I'm scared of injecting myself. Tengo miedo de inyectarme solo. What am I supposed to do? She has to inject herself. It's $5,000 worth of injections. She did it yesterday. But now she doesn't want to do it alone. I'm gonna tell her to call my mom. Llama a mami. O llama a Emily. The baby counts as somebody around with her. The baby can just look at her, inject herself. Huh? But she's gonna have to do it twice a day, morning and the afternoon and night.
Oh, the night.
It's twice a day. And the injection is not fun. The injection is not fun. I'll show you it when I have a chance. All right, let me just make my life easier. Pause the recording. All right, guys, resuming this. Hopefully at this point I would have edited the video appropriately. All right. All right, I think it resumed. All right, so the next portion would be to be able to do, I would be able to give you some numbers and you would be able to do the box plot with it and do the 5-number summary. I think that's important. So I don't know. First thing is you got to make sure the numbers are in order. So let's just put some numbers here, some nice numbers, not numbers that are bad. I mean, there's no such thing as bad numbers. There might be bad people, bad students, but that's only temporary because everything is dynamic, I guess. So let's say you have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll go ahead and just to make it interesting because we reviewed a lot of the odd ones. We have 10 numbers here. So the first thing is, what's 10 divided by 2? 5. And so that means the fifth one, in this case, the fifth one and the sixth one will be added together, right? Because when you have an even amount of numbers, you split it in half, right? And to do that, you're going to pick whatever the amount of even numbers are divided by 2 plus the next one, and you're going to add it and divide by 2. So you got to remember that. So if you had 20 numbers, it would be the 10th and the 11th. numbers respectively and divided by 2. All right, so all right. Yes, you have to take 13 plus 17 and divide it by 2. That comes out to 30 divided by 2, which is 15. So that's your second quartile. That's your median. Okay, so we gotta first find the, and she asked, what about the first one? Well, first we find the middle. And now we find the middle of the lower half or the median of the lower half, lower and upper. And we find the median of the upper half. So this guy here would be quartile 1. And this guy here would be quartile 3. Now, again, each, depending on how many numbers you have a few situations that can happen. And so you could go back to some of the previous videos where I did all the possible situations so that, you don't mess up. Because sometimes you have an odd amount of numbers and you pick the middle one for the first one. And then when you split it off, you have an even amount of numbers on the lower half and an even amount of numbers on the upper half. So then you have to average the middle 2 of the lower half and the upper half. But sometimes when you do that, you end up with the lower half being the middle and the upper half being the middle. Does that make sense? So let's just go ahead and write down our 5-number summary. Okay, my wife sent me a movie of her current injection. So I have to say good job to her because she wrote que gracioso. All right, wait, I'm downloading, it's 21 megabytes, so I gotta wait. 5-number summary. So what's our minimum here? 2. What's our max? 35. What's our first quartile? What's our second quartile? What's our third quartile? 3rd. Okay. So now let's make our box plot. Now, I think we talked about in class about the scale. In this case, it ranges from 2 to 35. So I think I should start at 0. I should go up by 5s. I think that's okay. Because then I gotta make 35 little lines or maybe do it in 2s. It's up to you. As long as you're consistent. Now, obviously, I think 10, a scale of 10 is kind of pushing it. Those lines got a little bit bunched up, whatever. I can simply erase it quickly and just reset. That guy's the one that got narrow. And then this was a little bit there. So 15, 20, 25, 30, 35, a little bit better. So we put a dot for 2. Put a dot for 2. We put a dot for 35. We put a line for 7. A line for 15. And a line for 30. And now we connect those lines to make a box. And then we attach the whiskers. And that's it. You just got an A on another quiz. Now, some of you might complain that why don't I have multiple questions? And I think on this quiz, it's fair to give you 4 different numbers. And the reason is I want to see you demonstrate that you know how to do each one of the situations. And if you mess up, then it's on you. Right? So I think it's okay to give you 4 different questions on this quiz. So can you imagine coming next class, I go give you the first one and you're like, okay, 68, 95, 99.7, 34, 34, 34.5, 2.35, and maybe you remember a 0.15. All right, that's it. And I'll give you the other one, which is going to contain empirical rule. Right? And then you answer those 2 questions. That could be another A. And I'll give you Shapeshift's theorem. I don't know, that could be an A. And I give you this one, but I give you 4 questions. So we're spending the whole time next class testing, basically. All right. I think 5. So 5 different assessments. That means I'm going to be miserable grading this stuff because I got to grade it for you and 7 other periods. But I would have 5 whole grades. And if you get 5 whole Fs, you just ruin your grade. Just think about that. Something super easy, but I'm making it easy though. I want to see if you have the basic skills. That's all. And then we'll spend about a week preparing for chapter 2 tests. And then the chapter 2 test is gonna be worth 4 grades. And if you manage to do well on those 2 tests, you can't help but get an A or a B in the class. Like it's gonna be very hard for you to get anything other than an A or B. Because right at that point we have 9 grades. In 2 or 3 weeks, almost by progress report, you have the opportunity to have practically an A in a class. For sure. Remember, we're only required to give you 1 assessment per week. By that time, I have 9. Yes. Shapeshifts? Okay, Shapeshift's theorem is the formula 1 minus 1 over k squared. So let's take a look at it. I'll drag it over here on the board. So Shapeshift's theorem applies to any distribution. To any distribution. And yes, be careful. So it applies for any distribution. And what happens is you got K. K stands for how many standard deviations you're away from the mean. So if you pick 1, you be 1, like this on each side. 2, you be 2. So you just kind of like, if I give you 2, for example, you put 1 minus 1 over 2 squared. That's 1 minus 1 over 4. That's 3/4. That's 0.75. So that's 75%. And so you would say on that theorem, at least 75% of the data must lie within 2 standard deviations from the mean. And that's it. That's all Shapeshift's theorem is. But I'll give you the K. K stands for the amount of standard deviations. So don't overthink it. That's it. That's all I want you to know Shapeshift's theorem. Yes, the calculator can do it. But you got to remember, at least is a key here. And it's a general rule, but it's shown that it's true for any distribution. For any distribution, it's true. But in order for it to be true, it has to say at least, because it could potentially be more. So by 2 standard deviations for any distribution, you have at least 75. You know, that's the key there. So don't overthink it. It's really easy. Got a few more minutes in class, so let's wind it up now. All right, so the last thing is z-scores. The last thing is z-scores. We did that briefly last class, at the end of class, right? So z-scores. So our z-score is x minus x bar divided by s. So that might be the first question in the quiz. I might ask you, like, write your z-score formula, and that's your answer. And then I might say the following. X bar is 200, S is 20. The distribution is approximately normal. Right? I might give you that. And I might say, which of the following are unusual? Like I might do that. And so A might be, all right, is 230 unusual? Right? And so you go, okay, Z equals 230 minus, well, I'll just write it all. Here's how I would do it on the test. I would do x minus x bar divided by s, which is 230 minus 200 divided by 20. And if you did that, you would get with 30 divided by 20, it comes out to 1.5. And you would say, no, that's not unusual. We're good. Because things that are unusual are 2 standard deviations or more, or negative 2 standard deviations or less. So let's say I give you B and I give you 245. You go Z equals X minus X bar divided by S, right? And then you would do 245 minus 200 divided by 20. So that's 45 divided by 20. That's a 2.5. And this one you say it's unusual. Why? Because it's unusually far from the mean. You got to remember that beyond 2 standard deviations, the empirical rule has each tail, if you add up 2.35 and 0.15, each tail is 2.5%. So between both tails at the extremes, you got 5% of the data. Only 5% will be in the tails. Only 5% will be in the tails. So, but it could also be in the opposite direction. It might be X equals to, let's say X equals to, I don't know, 170. No, let's make it 150. Z equals to 150 minus 200 divided by 20. So that's negative 50 divided by 20. So that's what? Negative 2.5. Yeah, this would be unusual too. So far, so good. I mean, 4 very simple quizzes. Or 5. Depending on how I feel like doing it.
Yeah, it's unusual because it's not.
It's unusual because of this. Let me actually make another line. Just in 5 minutes, I should be able to explain this very easily. So let's talk about why it's unusual. It's unusual. I'll show you why. So over here, I'll just drag it. I think there's enough space for you to see it. Here's the normal distribution described by this. You have 200 here. At 1s, we have 220. At 2s, 2 standard deviations away from the mean, we have 240. If you do it in the opposite direction, negative 1s, you got 180, and negative 2s, you get 160. Now, what we say is anything over here or beyond is unusual. Or anything over here and beyond in this direction is unusual. So 250 falls right here. And if you take 250 and subtract 200 and divide it by 20, because remember your S here is 20, and this is X bar, then you get 50 divided by 20, which is 2.5. It is 2.5 S's from the mean. Anything from here on is unusual. It's too far away. Anything from here or less is too far away. So that's why we're saying if you get it, what a z-score is it's the amount of standard deviation something is away from the mean. So for example, if you take 220 and you subtract 200 and you divide it by 20, you get 20 divided by 20 equals to 1. That's why all it's telling you is the standard, how many standard deviations is away. And later on, we'll discuss it more, but that's essentially it. All right, does that make sense? There, it's clear. Other questions or concerns? I pretended once again to be a teacher, guys. So stop recording.